Mr. Dady, and today we're going to talk about graphing systems of inequalities. Alright, graphing these systems is a little bit different than graphing systems of equations, because if you watch the other video, there are inequalities, you have to use dotted lines and shading. Now, don't overthink it. All you're doing is graphing two linear inequalities, and then wherever they cross over, that's your answer. And I'll show you that. I'm only doing two examples of this because it does take a little bit of time to do each one. Alright, so I'm going to break it down. My y-intercept is 0, 3. My slope is 2/3. So since that is positive, since my slope is positive, it'll give me a positive looking line. Now, I have it greater than or equal to so my line will be solid. Now for my orange one, my y-intercept is 0, -3, and then my slope is -4/3. Since that's negative, puts my line like that. Alright, is that correct? No, because I have greater than without the equal, so it's dotted. So all I have to do is that. Now you don't have to do all this, I just do it for the video, and I do it when I show this to help out. Alright, so now I'm going to graph the first one. 0, 3. And then my slope is 2/3. So I'm going to go down 2, then over 3. Just make sure that my line looks the same. Yes, it will be going the right way. And it's going to be a solid line. There we go. That is my red line. Now, for my orange one, my y-intercept is 0, -3. And my slope is -4/3. So I just need to make sure that my line looks like that. So I'll go up, 1, 2, 3, or no, rise and go up 4. 1, 2, 3, 4, and over 3. 1, 2, 3. Close enough. Alright, that is not correct. What we have to do is make it dotted. Now you can't do this on yours, so when you do it, just do it however you want. But now it's dotted. So that means that whatever your answer is, it's not going to be on the line. Alright, so now we have to shade. So we're going to do the red one first. And I'm going to erase this. So I'm going to plug in my point 0, 0, just like that's the way I do it. 0, 0, and I plug it into the equation. Y is greater than or equal to 2/3 x plus 3. Alright, now I plug in my 0, 0. So 0 times 0 plus 3, that gives me 0 is greater than or equal to 3. Does that make a correct statement? Is 0 greater than 3? No, it is not. So I'm only looking at the red line here, not the orange, only the red. So 0, 0 is right there. If this is a false statement, do I want 0, 0 as one of my points? No. So I shade all of this. So that means anything up there will be an answer. So now, I do the same thing, but with my orange one. So I get y is greater than -4/3 x minus 3. And I plug in 0, 0, just like I did before. So I get 0 is greater than negative 4/3 times 0 minus 3. 0 is greater than negative 3. Is that a true statement? Is 0 more than negative 3? Yes, it is true. So what that means is I want 0, 0 in my answer. 0, 0 is right there. So when I shade, do I want to shade this side that doesn't have 0, 0? Or this side that has it? The side that has it. Alright? So now, all of my answers for this system of inequalities is in this area. But it is not on this line because it's dotted. So any of those can be your answer for the system. Any point in the double shaded. Down here won't be an answer. Down over here won't be an answer. Down here is not an answer. Any point here. So I can pick 2, 7. No, negative 2, 7. That's an answer. Negative 4, 8. That's an answer. I can even pick one on this line. So 0, 3. 0, 3 is an answer. Alright, those are all answers for this, and that is how you graph it. Alright, then all of these. But what won't be an answer is this right here. 1, 2, 3. Negative 3, 1 is not an answer because the orange one is dotted. Even though it falls in there, it's not because that line is dotted. As you've seen in my other videos, you have, when you graph, it has to be in the form of y equals mx plus b. Neither of these are in that form. So what we are going to do is solve for both of them. All I did was move that one over here. So now I'm going to solve for this one first. Subtract 3x, subtract 3x. Gives me 2y that I brought down. Gives me negative 3x minus 2. Divide the whole thing by 2. There we go. That is correct. Now I had to bring down my sign. Did any point throughout this, did I multiply or divide a negative number? No, I did not. So my sign stays the same. Now over to this one. Subtract the x. Divide by negative 2 gives me y 1/2 x minus 1. Now, did I divide or multiply by a negative number? Yes, I did. Right here. So that switches my sign around. That is the biggest thing that people miss here. It's not switching that sign around. So you have everything else going on. You're trying to get the problem done. It's long. There's so much you can mess up on this. Don't let that be it. Right, so now I have my 2. I'll graph my green one first. So negative 1, and then up 1, over 2. I'm going to have a positive slope here because that's a positive number, and it's going to be solid because I have the equal sign. Now, I'm going to graph the second one. It starts at negative 1 also, but it is a negative line because that's a negative number, negative slope, 3/2. So I'll go up 2 over 3. And will it be solid? No, it will not. It'll be dotted. There you go. And that is just graphing them. We still have to go through finding the points for them. Or see which side I have to shade. So I'll do the green one first. X minus 2y. So this is the part where I add in 0, 0. So 0 minus 0 So 0 less than 2. Yes, it is. That makes a true statement. And because it's a true statement, we want 0, 0 in here. Alright, so we're going to shade the side with the 0, 0. Doesn't have to be a great shade job. Now it doesn't matter which one you put it in. If you put the 0, 0 in here, or you put it in this equation right here, it doesn't matter. You still get 0 is greater than -1, which is a true statement. So we're all good. So now we do blue. Plug in the point 0, 0 to our blue equation, which is 3x plus 2y is greater than -2. I plug 0, 0 in, it gives me 0 plus 0. 0 is greater than -2. Is that a true statement? Yes, it is. So I want the 0, 0 in it. So I'm going to shade that side. So now, my answer is everything on this line, not on this line, and everything in here. Any point in here can be your answer. It doesn't matter which one it is. You can do 0, million. It's going to be an answer for these two. All right. This has been graphing systems of linear inequalities. I only did 2 examples. It's a lot of work, a lot to mess up. Just make sure you're going through the steps correctly, and good luck.